Okay, so I'm going to talk about how to solve quadratic word problems given an equation in vertex form, and we're going to use a rocket example. The example is that a rocket is launched from a platform. Its height in meters x seconds after the launch is modeled by the function h of x equals 4 times quantity x minus 4 squared plus 100. So that number there is plus 100. Answer the problems using this function. Okay, so we're assuming that this function is accurate, and we're going to take a look at the questions. But before we do that, we're going to take a look at what the graph looks like. This part is not required. We're just taking a look at the graph because I recommend that you graph it if you haven't done tons of these problems and don't know what the graph is going to look like right away. It's a really good practice. And also because it is really helpful to understanding what's actually going on in the problem, okay? So because the equation was given to us in vertex form, the vertex is very easy to find because whatever's subtracted inside the parentheses is the x value of the vertex. So that's 4, because 4 is subtracted, and then the outside number is the y of the vertex. So I know straight off the bat that my vertex is 4, 100. And then I'm going to need a couple other points to graph my parabola. Excuse me, this equation is actually not right. This should be a negative 4. Okay, so h of x equals negative 4 times quantity x minus 4 squared plus 100. So because there's a negative coefficient in front of this, that means that my parabola is going to face down from 4, 100, and I need at least one other point. So I'm just going to plug in a couple of points near the vertex. And I'm going to plug in 0 because that's quite near to the vertex, and the y-intercept is often very useful. So I'm going to plug in 0 to x, and I'm going to solve for y. So when I do that, 0 minus 4 is negative 4. Negative 4 squared is positive 16. Positive 16 times negative 4 is negative 64. Plus 100 is 36. So if I plug in the number 0, I'm going to get an answer of 36 for the y value of h of x. So that's going to be another coordinate. If I want, I can also plug in 8 just to give another number. And I'm just picking these numbers. You could have picked 3, 2, 1. Those would have all been good. 5, 6, 7. Those would have all been good. But I just happened to choose 0, and I'm going to choose 8, okay? Because I'm going to show you what happens. So I'm going to plug in 8 for x. I'm going to solve for y. So 8 minus 4 is 4. 4 squared is 16. 16 times negative 4 is negative 64. Sounds very familiar. Negative 64 plus 100 is 36. Again, it's going to have an answer of 36. Now, I did not actually have to plug in 8 to know this because whenever I have a vertex, my parabola is always the exact same four from the vertex on either side of it. So if 4 below, if the x value 4 below gives me an answer of 36, then the x value 4 above, which is 8, will also give me the same answer of 36. And I'll show you what this looks like. So I noticed that my x values are quite small, so I'm going to go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I noticed my y values are quite large, so I'm going to go so that I can at least hit 100. I'm going to go by 20s. So this is 20, 40, 60, 80, 100. I'm going to plug in 4, 100. That's going to be about here. I'm going to plug in 0, 36. So that's going to be 30, 36. And 8, 36. That's going to be over here, roughly. And then I know that my parabola is rounded and it's slow at near the vertex, and it speeds up. So if I'm going to estimate what it looks like just as a rough graph, then this is what it's going to look like. Okay, remember that this is an estimate, so I don't actually know that it crosses the x-axis at 10. That is just because I didn't actually plug it in to find out. But I know this point for sure, I know this point for sure, and I know the vertex for sure. Okay, all right, so that's my sketch. So I know my maximum is here, and now I can explain again. 0, 36 I plugged in, so I didn't actually have to plug in 8 because this is symmetrical around the vertex. I can even draw a line straight down through 4. And so if 4 to the left of the vertex has a height of 36, then 4 to the right of the vertex, which is at 8, will also have a height of 36. The height is always exactly the same, equidistant from the vertex. Okay. All right, so that's my graph to understand what's going on. Now let's take a look at the first question. Okay, so question number 1. Find the height at the time of the launch. And I just put in the word "the" here. So find the height at the time of the launch. So at the time of the launch is when the rocket has been moving for 0 seconds, because that's exactly when it launches. So when they say it at the time of the launch, that means the time equals 0. That's what it's telling you. They're not going to explicitly say it, but they have to give you some sort of number in there, secretly or explicitly. So at the time of the launch, it's the time equals 0, no time has passed. So I'm going to plug this value of time for the equation, and they used x, so let me switch that to x. So I'm going to plug in this value into this equation to solve for what the height is at 0 seconds. So h of x equals -4 times 0 minus 4 parentheses squared plus 100. -4, this is -4 squared. -4 squared, you have to square the 4 and the negative sign, so that becomes a positive 16. This -4 times 16 is -64. And that's going to end up being positive 36. So remember that h of x is the name of the function, but whatever answer I get for this equation was the same thing as this original equation up here is the same thing as y equals -4 times x minus 4 squared plus 100, but it's just that the name of the equation is h. So that means my y value is 36. That's my answer for that. So at x equals 0, y equals 36. So the height is 36, and it says that the height is in meters, so 36 meters is the height at the time of the launch. Okay. If you look at the graph, which is to understand what's going on here, this is the projection of the movement of the rocket. So what's happening is when 0 seconds passes, this is the height of the launch. When 4 seconds passes, this is the height of the launched rocket. So when they say find the height at the time of the launch, you have to look at your graph and see how high it is at 0 seconds. Notice that the answer is not 0 meters because the rocket is actually on a platform, so it's actually up in the air, which is consistent with how rockets sometimes are launched. They sometimes are on platforms and not exactly on the ground. Okay. All right, so then the next question is this one, and I didn't write B because some worksheets don't have this as this B, and some people have a worksheet in front of them, so this might be C for you, but just a different question, okay? So you can find it on your worksheet if you have one. After how many seconds does the rocket reach its highest point? Okay, so as soon as you see the word highest, that should be a key word to you. When you see the word highest, most high, most, fastest, most expensive, least expensive, any extremes, telling you that it's a maximum or minimum, you should know that you're looking for the vertex. So this is asking for the vertex because of the word highest. And because this is in vertex form, you should be able to find the vertex right away. We already did that before, so remember that the vertex in vertex form is just the opposite, whatever subtracted inside the parentheses, comma, whatever the number is that's being added outside of the parentheses. So that's my vertex. The next thing is they're asking for, are they asking for the x value or the y value? Where the x value stands for time, because it's the seconds after launch, and the y value represents for height in meters. So after how many seconds does the rocket reach its highest point? Well, they're asking for the seconds, so the answer is going to be 4 seconds because that's what they're asking for. So the question is about how many, after how many seconds. So that's the key, that we're looking for the x value and not the y value. Okay. If I were to look at the graph again, again, you can see that they're asking for when does the rocket reach its highest point, where in the graph you can tell that that's going to be this point right here. So you're looking for the coordinate of this point, which happens to be called the vertex. And so that visually helps you understand what the question's asking. I'll do 2 more things about this problem, but we're going to do that in a separate video because this one is getting quite long.